Hello everyone, welcome back to the SAP 2000 Basic Course. In this lesson, we are going to talk about load settings. Once we have defined the support and the end release, we need to start applying loads to the structure so that we can absorb deformations and bending moments. Today we will cover three main topics: type of loads, load assignment, load combinations. Let's begin today's lesson. First, open the model saved from the previous lesson and adjust the view windows to a suitable size. Let's move on to defining load patterns. Go to Define, Load Patterns. In SAP 2000, all loads belong to load cases, and the load cases are built on load patterns. In this system, this is already a default load pattern called dead, which represents dead load. We can add many different load patterns, such as dead load, live load, and wind load. In our current model, a dead load pattern has already been created. The self-weight modifier here is important. By default, it is set to 1.0, which means SAP 2000 will automatically include the self-weight tool of the structure. In the analysis, when this load pattern is active. For other load types, such as live load and wind load, self-weight is not included. So their self-weight modifier is typical 0. In this lesson, we are going to add two new load patterns, live and wind. For the live load, set load pattern name to live. Type to live. The self-weight modifier is automatically set to 0, which is what we want. Click Add New Load Pattern. For wind load, set the load pattern name to wind. Type to wind. The self-weight modifier is also 0. Here you will see an option called Auto Lateral Load Pattern. There are many codes available here. If you choose a code, SAP 2000 can automatically generate wind forces during analysis, so you don't have to input them manually. However, in this course, we will demonstrate manual input of wind loads, so we are not using the auto lateral load function here. Simply click So we choose none. Simply click Add New Load Pattern, then click OK. Now we have three load patterns defined: dead, live, and wind. For this lesson, we will demonstrate the following loads. On this beam, a concentrate load of 100 kilonewton downward at mean span. On these two beams, a uniform load of 10 kN per meter downward. For wind loads, on the upper story, 80 kN to the right in total. On the lower story, 60 kN to the right in total. To simplify, we will distribute the wind loads equally to the joints. On the upper story, 4 joints, each 20 kN to the right. On the lower story, 4 joints, each 15 kN to the right. Let's start by applying the concentrated live load at the mean span of this beam. Click the midpoint joint of the beam. Then go to Assign, Join Loads, Force. For load pattern, choose Live. For coordinate system, use Global. The force is minus 100 kN in the vertical direction. We usually choose Add to existing loads in the options, meaning the new load will be added on the top of any existing loads at this point. Click Apply. Now you will see a minus 100 label at that point. You can run in to confirm that it shows minus 100 if you need it. Click OK to close the dialog. Next, we will apply uniform live loads of minus 10 kN per meter to these 2 beams. Select the 2 beams, then go to Assign, Frame Loads, Distribute. Choose Load Pattern, Live, Direction, Z, Uniform Loads, minus 10 kN per meter. Again, choose Add to existing loads. Then click Apply. The uniform load has now been applied to those beams. Now we will apply the wind loads at the joints of the 2 floors. As mentioned, we will simplify the wind distribution. Up floor, 4 joints, each 20 kN to the right. Lower floor, 4 joints, each 15 kN to the right. First, select the 4 joints on the upper floor. Go to Assign, Join Loads, Forces. Since this is wind, choose wind as the load pattern. Choose System Global. The force is 20 kN in the global X direction, so set force global X is 20, and the others is equal to 0. Click Apply. Then click OK. Repeat the same steps of the lower floor joint, but use 15 kN instead of 20 kN. Next, we will move on to the load combinations. Go to Define, Load Combinations. Click Add to add new combo. For the first combination, we will define 1.2 dead plus 1.6 live. So in the load case column, select dead. Combination type, linear static. Scale factor, 1.2. Then add another row, select live. Scale factor, 1.6. Click OK to finish this combo. Now click Add New Combo again to define a second combination that includes wins. So we choose dead with scale factor 1.2, wind with scale factor 1.0, live with scale factor 0.5. And if needed, you can add additional wind cases. After you finish entering the rows, click OK. Now Combo 1 and Combo 2 have both been defined. These load combinations will be used later when we perform number design checks. SAP2000 will use these combos to determine whether each member's demand exists its allowable capacity. Later on, results will be displayed as a demand capacity ratio, so you can see how each member is performing under the combinations. Click OK to close the load combinations dialog. That's all for Basic Course Lesson 7. In this lesson, we learned how to define different load patterns, how to apply loads to joints and frame elements, and how to set up load combinations for later analysis and design. Today's lesson ends here. If you enjoyed this course, please remember to share this, subscribe, and turn on the notification bell. See you next time.